Come on, everyone. Let's start off. This was the last thing that we did. Next one. Let's say we have a hemisphere. Let's say solid hemisphere. Let's take a normal one. And outside the pressure is P naught. Constant. So how will the pressure act? The pressure will act like this. Sphere or radius r. Find force on the curved surface of the hemisphere. Let's get this. On that entire curved surface, I want you to find the force acting on the curved surface. Remember, you can't directly say P naught into area. That is wrong. Why? The force is vector quantity, right? All the forces are not in the same direction. So you directly can't say pressure into area. That is a blunder. Force is a vector quantity. You can add only the components. You have to integrate. Get it? There's a much faster way, but I want you to do with integration. How do you choose an element? How do we remember how to choose elements? Strips, circular strips. Answer comes in terms of, what do you think it will come in terms of? You type now what answer you got. Okay, great. So the question is, what is F here? If you say F in the FPD, right, you should have drawn F. What is F here? P naught pi r square. See, let me show you the integration, and with an FBD, it's actually more easy to figure it out. But whenever you take a sphere, this is how you choose elements. D theta at an angle theta. And how is the pressure acting? Pressure is acting this way. So if that is theta, this is theta. So on this strip, the force acting, it is not at one place. It is like a crown axle in every direction. So the resultant will be pressure P naught into area will be 2 pi. What is this radius here? This is r cos theta. I hope everyone remembers how to choose the element. And this strip will be r d theta. P naught into dA, that is force, and force ka sine theta. Isn't it? All the horizontal components cancel out, only the vertical components add up. And dA is nothing but 2 pi r cos theta, circumference into width r d theta. Therefore, the force on this curved surface, you have to add all these vertical components of forces. Horizontal components cancel out. This is your vertical component. Integral P naught 2 pi r square sine theta cos theta d theta. Limits will go from 0 to 90. That would be P naught r square 2 sine theta cos theta is sine 2 theta d theta 0 to 90. This would be half cos 2 theta minus sine 0 to pi by 2. That would be P naught r square minus half minus 1 minus 1. That is minus 2 P naught pi r square. So that's how you actually get it. Now, the more easier way to actually, you could have said this. Think of it like this. This is important. I call this thing projected area. You will not find this in books, meaning they won't be using this word. They might use some other name, but technically there is no concept as such. But this thing comes in a lot of chapters. This comes in at least 6 chapters in physics. So quite an important concept, quite useful. What this thing says, imagine you take any random surface. It doesn't matter. Now, if the pressure is equal everywhere, what is the net force acting on this system? F net is 0, agreed? If you take a massless shell and put it in a room with a pressure P, net force should be 0. If net force is not 0, what will happen? This will start moving randomly, right? Just imagine you keep a massless object in the room and it starts flying everywhere. There's a ghost in the room. Kidding? So what this implies is this random amoeba shape plus this flat disk. Since the net force is 0, the force on the curved surface must be equal to the force on the flat surface. So this is how you can write force on a curved surface, any curved surface, is pressure into projected area. What's a projected area? A flat area which makes an open surface into a closed surface. This is your formula now. But this is valid only for constant pressures. Be careful. The previous result I derived in the last class, that is for flat surfaces. This is for discs, this is for plates. I hope you're getting the difference. This is for 3D shapes. Both are not same. Don't mix it up. The previous one, it was a plate placed in the water. The force on one side of the plate is pressure at center of mass into area. This is some random curved surface. And from there you get it. So if you say it's the same answer, so for the hollow sphere, what is the projected area? The disk, isn't it? Quite a useful concept. We will again encounter this thing in surface tension. We'll again encounter this thing in electrostatics, magnetism, modern physics. There's one more chapter. 6 chapters it comes. EMI and magnetic force. Yeah. Clear with this concept? We call it projected area. In generally HCV and all, you won't find this, but in some books, it might be written with some other word. End of the day, what matters is the concept. Clear? So let me show you some examples on this. The only problem is it works when the pressure is constant. Now, why I want you to do with the integration? What if pressure is not constant? Let's say this thing is placed inside the water. Then what would have been the answer? That's the next one we will try. Force on the curved surface of a hollow hemisphere. See, you're talking about curved surface. Why does the liquid care whether it is solid or hollow? How will you know what is inside? All clear with this? Everyone got the integration? Abhinav? Anusha? Anika? Got the integration? Maulika? Now, using the same integration, can you do this for me? 1 second. We'll finish off this projected area. का थोड़ा examples और करते हैं. Let's say, example, let's say if I take a cone like this, radius r, and let's say the pressure is P naught. What is the force on the curved area? Force on the curved surface. What is the projected area for this? This, na?
Base for the cone.
Again, it will be the disk only. Like I said, remember the definition of projected area. A flat area which will make an open surface into closed. What is the meaning of open and closed? When you say open surface, from outside, there is no inside and outside. Actually, you can come out outside without touching the plate. But if it is closed, you have to cross the surface. This is even a good example. So wait. So this guy would be P naught into projected area is pi r square. What about this guy? Half cone. Height is h. This is this is 2r. So let's say pressure is P naught here. So what is the force on the curved surface of this part? You're getting how it is? You kept a cone. I want the force on the left half of the cone. मुझे पूरा cone पे नहीं चाहिए. Because if it is a full cone, it will be P naught into pi r square. What is the force on curved surface of left half of the cone? Take a minute. It's a good one. Symmetric figure? I don't know what you mean by that. I want only on the curved surface of the left half of, okay? Left half of the cone. Again, remember the definition, a flat area which will make an open surface into closed surface. So if you want to make this half cone into closed surface, कितना areas चाहिए? This is equal to 1 half disk plus 1 triangle, na? Isn't it? You need a triangle on the right side and you need an half disk at the bottom. So this projected area will be this guy and this guy. There are two projected areas here. So force कितना होगा? On this, the force will be P naught into pi r square by 2. On this thing, the force will be P naught into what is the area of the triangle? Half base into height. So force on the curved part will be P naught r into h I cap minus P naught into r square by 2 j cap. Meaning logically, socho na, if the pressure is like this, shouldn't there be two components? If you look at that curved surface, it is not horizontal or vertical, it is at an angle. So there will be a vertical component and a horizontal component. Is this logic clear? So if I give you some open surface, you can close it with any number of flat surfaces. And एक flat surface ka find the force and equate it, right? I hope this logic was clear.
Yeah.
Please check out the second example. It's a pretty good one. Ha, Arjun.
In like same thing but half cylinder, we would have taken only the vertical area, right?
Half cylinder to would have been a rectangle, right?
Yeah.
वो भी डाल देते हैं. So if you take a half cylinder, problem is I can't draw cylinder properly. Here. Yeah, I got it. My artistic skills are improving. Now, the projected area for this is what? This guy. And that would be P naught into L into 2R. Isn't it? This diameter will be 2R and this length will be L. Why is the force from inside and not outside? I don't know what you mean by that. Anisha? Inside and not outside, matlab?
So I was asking about the direction of the pressure which you do, like,
इसका?
हाँ,
हाँ, obvious ना रे, देखो ना. Actually, how are you getting projected area? इसका force और इसका force ना?
yes,
These three is 0 na. The force on this should be minus of this and minus of this na.
got it. All right.
Making sense?
Yeah.
I hope everyone is getting this thing, the direction part.
सिर्फ फुल सिलेंडर का भी प्रोजेक्टेड एरिया से निकाल सकते हैं
0 na. Full cylinder, like if you don't take the top part and the bottom part, it is closed. वो तो cancel हो जाएगा ना कोड. वो सिर्फ हाँ तुझे चाहिए तो नीचे से ले सकते हो, but fine. That it's anyway it's a flat surface. You could have calculated normally. Everyone clear with the curve? Now, if you combine this guy and the previous one, what was the previous one for the sheet? We get even a better result. again, let's say we have some weird surface like this. I can't draw this properly. Should try. Something like this. How to say this thing? If there is a cake, anytime did you put your hand and try to take a piece without using a proper knife? If you put your hand and try to steal a piece, कितना weird shape आता है हाथ में? Something like that. Able to visualize? You didn't know what to visualize. Let's say your sister ka birthday is there and there's a cake. She cut it and took a small piece and went to give someone. In the meantime, you're hungry and you couldn't bear it. You put your hand like this and you tear a piece out. Now you're able to visualize, right? So something like that. It's a weird shape. So what this statement tries to say is, now whatever force is acting on this curved surface, it's acting in all directions. And again, it is in a liquid, okay? So the depth is also, pressure is changing. The force on the curved surface, again, horizontal force, not everything. Is pressure at center of mass into center of mass of the projected area. Meaning for this random piece, find the projected area, and this projected area ka find the center of mass. Find the pressure there and multiply with the projected area. That would give you the force on the curved surface. Let me see if I can get another weird shape. Let's say this only is there. Half thing. Let's say something like this. And this thing you're immersing in a liquid now. This is immersed in a liquid. So outside is pressure P naught. So if you go to pressure depth X here, pressure is not constant. Liquid density is rho. So at a depth X, pressure will be P naught plus rho Gx. You're getting it? So if you put something in a liquid, the pressure does change. So for this surface, locate the center of mass, which will be the center in this case. So force on that surface will be, again, horizontal force. Pressure at that center of mass into projected area. So whatever is the depth. Will be P naught plus rho Gr into pi r square. That will be the force on this curved surface. This formula is valid for constant pressure and also if pressure changes linearly. But remember, the only problem, it gives you only the horizontal force. It does not give you the net force. Whereas this formula gives you the net force. Did you see you got the net force, right? I cap, J cap. But problem is it is valid only for constant pressure. You're getting, if you get something, you're losing something else. These are all just variations of that thing. Have a look at this. If you take any random surface, uska projection, that will be a flat area, isn't it? that flat area ka center of mass. So you can find the force on that part. That will be the horizontal force on this. Again, same logic. Whatever is this horizontal force, this should be the same horizontal force, right? Or else the piece will go left and right. Check it out.
The COM of the projected area सबका क्या मतलब है? You wrote pi r square in the end only, no?
वो तो डिस्क ले लिया ना मैंने. If I have taken some other weird shape, then उसका area क्या होगा? Suppose if this was some projected area like this, so उसका area लेना पड़ेगा ना.
तो COM का मतलब क्या है?
Pressure at center of mass ना.
Pressure at COM multiplied with COM of the projected area.
Oopsie, sorry. Pressure at center of mass of projected area. So projected area का center of mass into projected area. I was just testing you guys who will find out the mistake. Utsa has found out. That was a mistake. Do correct it if you have written. Clear? Let's see a question based on this. And then I'll show you the integration part again. But are you getting why this will work? Simple logic. If this is not true, that means this horizontal force and this horizontal force are not equal. That means this random cake piece will go left and right. Simple as that. So without integration, you can prove stuff. Can I turn the page? Aryan, clear na? Ali, Abhinav? Who is missing today? Udayan is missing. Next one. So this is a cylinder. It doesn't matter whatever it is. Solid or hollow is the same thing. So this solid cylinder separates two liquids. As shown. So one side you kept a liquid like this, whose height is r, and its density is 2 rho. The other side you kept a liquid whose height is h and the density is 3 rho. And the system is in equilibrium. Find h if system is at rest. Basically, from the right side, 2 rho is pushing. On the left side, 3 rho is pushing. Densities are different, heights are different. But the system is in equilibrium. That means both of them are exerting equal force. Find h, the height of the 3 rho liquid if the cylinder is at rest. I hope the question is clear.
तो सिलेंडर का हाइट चाहिए होगा ना?
Nah, you don't need. What do you think you need? Assume करके try करो. Cylinder height क्या होगा? 2r होगा. उसमें क्या है? Length बोल रहे हो. Cancel हो
हाँ,
जाएगा record.
ऐसा
Cancel हो जाएगा. Is the flat surface in contact with the two liquids? What do you mean by that? Palaksh? Which flat surface? Ground बोल रहे हो? Unmute and tell now. Is the liquid separated by the flat surface or the curved surfaces? Is my diagram so weird? Kya? Cylinder is like this, na? Cylinder is in the middle. Arey, if that was the case, I would have drawn the diagram like this, na re? ऐसा draw करता हूँ ना मैं. Liquid is separated by two liquids. Why will I show you the front view? You guys are confused about this? I know my diagrams are bad. इतना भी bad नहीं है रे.
आराम से करो.
No, do you know how this? Palaksh, clear na now? Anusha, did you get it? If that was the case, I would draw like this only, na re? Yeah, I know. Don't taunt me about my diagrams. I do feel bad. I'll take revenge in the next exam. I'll make the paper tough. What else can I do? Poor innocent physics teachers. Let's get this. अच्छा title है ना वो? Poor innocent physics teachers. Your seniors revision is starting from tomorrow. Round 2. I think I posted in your group. I was planning to delete it. Then I deleted for me. I forgot to delete for everyone. Now I can't access them. Once I delete for me, so I can't delete for everyone, right? गया था वो. ठीक है. Any answers? 2r/3 नहीं है. God, root में आएगा answer. Answer root में आएगा. I know where you goofed up. Anika, Aryan, both of you got it wrong. Try. Give another 30-40 seconds and I'll show you. If you know the previous concept, this question is quite easy, or else this thing looks messy. Show you root 3/2. Okay, let's see. Now, see, first thing for the green one, I'll just take the whole thing better. Again, listen to the logic that we said. We said the curved surface ka projected area. So if you take this guy, so this guy ka projected area will be what? Won't it be a rectangle? Means if I try to draw the whole thing, how do I draw these things? This is better. Now, if you just take half of it, won't this be the projected area? For the left half here, the liquid is filled only till here. The projected area will be a rectangle, na? What is the height of the rectangle? This is R, this is L. So the force will be, this is the center of mass. So I will just draw here. So this would be the rectangle there. So the force will be rho to rho G. This height will be half of the height. So that is R/2 from the top. So 2 rho G R/2, that is the pressure, into area is L into R. Agreed? Similarly, for the red one, if you take the projected area, the left side, the projected area ka height will be H and the length will be L, and this will be the center of mass at a height of H/2. So this force will be pressure 3 rho G, height is h by 2, and area is L into h. Is that making sense? So basically, one projected area will look like this. Height R, rectangle. The other projected area will look like this. Height h. You have to take the center mass of these 2 points here. And at that point, you take the pressure into area. So if you equate these two, you end up with 2 rho G R by 2 L R. This is the force on the right hand side. 3 rho G h square L by 2. 2 will cancel. This will be 2 R square is 3 h square. H is equal to root 2 by 3 R. Is that clear what we did? The projected areas for that curved surface will be rectangles, no? Wait, I can draw it better, I guess. Something like this. That would be the projected area. Next question. Clear, no? Everyone? Anyone not clear with this, what I did? So this thing, right? This cylinder is there, na? You could have taken actually any weird shape, meaning you're getting this is the front view. So the cylinder is like this. You're getting the front view is this, and let's say you fill up the liquid till here and fill up the liquid till here. I don't care what shape you take. I will just take this liquid ka this projected area, and this liquid ka this projected area, and the story will be the same. I get in the logic. Whatever is a curved surface, usko project. It's like when I say projection, think of like this. If I take a cylinder and put it on a light, what kind of shadow will you get? Won't you get a rectangle? So the projected area is simply the shadow when you put a light on that object. Think of like that. This is a good one. Now the same question, this guy, I will leave it to you. This guy is a homework actually. You try, that is better. So this question, you try this as a homework. What if you keep this sphere inside a liquid? Let's say this is 2R. Density is rho, outside is P naught. Now find the force on the curved surface. Now see what happened. The pressure is not constant. As you go down, the force will be more and more and more. So now we can't use projected area. Are we यहाँ पे? It doesn't matter, Nare. Because P naught is everywhere, isn't it? P naught will cancel. In this case, P naught is same everywhere. It will cancel off. Is this question clear, everyone? So you try this thing. So idea is the same. Let's see how will you approach this one. Later on, I'll teach you buoyancy force, right? With that, you'll get this answer even faster without integration. But you try to integrate and see. Clear. Next one. So we have a U-shaped pipe here. On one side, we have density rho. The other side we have density 2 rho. This is x. This is 2L minus x. This is x. This is 2L minus x. That means each liquid ka length is how much? 2L. So the first question is find x in equilibrium. Second, the container is accelerated horizontally. So you accelerated the whole setup with A. Such that x is equal to L. X is equal to, let's
Sir, बाहर
say,
P0 है क्या?
outside P0 only. It doesn't matter actually.
हाँ, ठीक है.
Such that x is equal to L. Find A. Get it? Udyan forgot there's a class. Let's get this, everyone. So if you accelerate the container, something will happen and the liquid will come exactly in the middle. So find acceleration. Get them both. X is 12 by 3. We have one answer, others. X is equal to 2. L by 3. Okay, we have 2 L by 3s. Might be right. Get the second part also. Find the acceleration if the x becomes equal to L. Yeah, x is 2L by 3, A is G by 3. Okay. The first was easy. Since the liquid is in equilibrium, consider a point A here and consider a point B here. And if you draw FBD of this liquid, this is 2 rho. This is rho. So this side will be pressure of area into area, pressure at B into area. Since it is an equilibrium, PA is equal to PB. PA is nothing but rho G, the height, 2L minus X, P naught. This will be P naught plus 2 rho G X. We end up with 2L minus X is equal to 2X, X is equal to 2L by 3. That was easy. A is G by 3. Okay. Now in the second case, if X is 2L by 3, meaning exactly it came in the middle, that means the height is same on both the sides. So this height became L. This height became also L. So if I take this point as A, and if I take this as point B, and if I draw the FBD of this part, and remember the whole setup is accelerating. Pressure at A into area, pressure at B into area, and this is accelerating. If you see, I'm just drawing FBDs, I'm not doing anything new here. This part was 2 rho. This part was rho. This is length L, and this is also length L. Because it's the midpoint, the total length is 12. So pressure at A into area minus pressure at B into area is the total mass is rho into area into length plus 2 rho into area into length into acceleration. PA will be P naught plus rho GL minus P naught plus 2 rho GL. A cancels off, and this guy would be 3 rho LA. A is equal to minus G by 3. Minus indicates what? It is not going right, it is going left. I hope you all got the minus sign. So the system is not going to the right side, system is actually accelerating to the left. The sign will take care of it even if you take a wrong direction. Please check out what I did. I just did FBDs, I did nothing, no big concepts as such. This is how you solve these kind of questions. Take a force and finish it off. Clear? Next thing. Any doubts on this? Neil, clear with this? Vidyut? Got this? Malika? Swastika? Got this? Aryan, clear, na? Rehan? Perfect. Next one. We have a container or a cylindrical tube rotating with omega, filled with liquid, density rho. This is x is equal to 0, this is equal to x is equal to L, and this is some distance x. Find neglect gravity. Find Px minus P axis. So Px is the pressure at a distance x from the axis. So now if this is open, then it would be P naught. But if it is not open, we don't know what is the value. So what you can find is a difference in pressure. Anyone remembers we did a question like this somewhere? Where? Anyone remembers? A rod of length L, mass m is rotating with omega. Find the tension at a distance x. And then remember how we choose the element? Distance x, take a small dx, and we did exact same thing. Sirf yahan pe pressure tha. Try, you got a minute. This is not the actual question. But the result is important. This is a standard result which you need to remember. You can directly, sometimes they'll ask in the exam. Cylinder radius. We don't need radius, it will cancel off. Radius will always cancel off. Force will require area. This is the best part about pressure, na? Pressure doesn't care about area. Force will be pressure into area. Let's see. Then you can take it as cylinder, doesn't matter. Rho omega square x square. You're missing a 2, Anika. See. Set a distance x. Consider a small piece here. Dx. What are the forces? This will be pressure into area. This is, let the pressure increase by small amount, P plus dP into area. Remember, the convention is always we assume pressure is increasing with x. Even if it is tension, we always assume it is increasing. Let the signs take care of it. The centrifugal force, dm omega square x. This is your centrifugal force. If I use centrifugal force, where is the observer? On the body. Now, apply the forces here. We get dP into area will be dm omega square x. So the small difference in pressure. dm is how much? Density. Area width. That is your mass density into volume. Omega square into x. There, A got cancelled. So dP will be rho omega square x dx. Limits. When x is 0, pressure is at the axis. You can't assume it is P naught. No one said it is open. This is Px and x. So we get a pretty good result. So pressure at a distance x minus pressure at an axis. The difference is rho omega square x square by 2. Definitely mug up the result. Standard one, but quite a useful result. Exam like mains or bits, they'll ask you such things directly. Now using this, can you solve this? So I took a U-shaped tube here. And you started rotating from here, not in the center, but to the side. The liquid will be filled here. This is H1. You're rotating with omega, and this is H2. Find H2 minus H1. It's based on this question only. So if you don't know the result, you can't solve the B part. So you're rotating a U-shaped tube there, not from the center, but to the L by 4 from the left hand side. So the heights will be different. Find h2 minus h1. Answer will come in terms of omega L and G. Try. You got 2 minutes. Omega square L square 4G. So this is your axis. This is point A and this is point B. Now see the formula you can't apply between A and B directly. You can apply between B and axis. So PB minus P axis is rho omega square x ka place mein 3L by 4 whole square by 2G. G is there, G is not there. 2. PA minus PX. So again, you can compare between A and axis. Rho omega square L by 4 whole square by 2. Subtract them. You get PB minus PA. This will be rho omega square by 2. That is 9L square by 16 minus L square by 16. 8L square by 16. L square by 2. PB minus PA is P naught plus rho GH2, the vertical height. Minus pressure at A is P naught plus rho GH1 rho omega square L square by 4. So H2 minus H1 is omega square L square by 4G. Check. That's your answer. Have a look at this. So we just use the formula 2 times, assuming this is one test tube and this is one test tube. You directly can't go from A to B. You can go from A to axis and B to axis and then finish it off. That way, this question is quite good. So in the exam, they'll ask you the second part. So first part ka result you should know. Clear? Next one. Any doubts on this? Anyone not clear? Please. Others who messed up, see why it went wrong. You won't get rho actually. Rho gets cancelled. You guys forgot to cancel, I guess. Next one. Turning the page. We have a square plate. So on one side, right, it is filled with liquid. So it's a square plate of side A. Which is free to move. right? Blocks the water. So to keep this plate at rest, someone has to apply a force, F external, and this force is applied at a height h from the top. As shown with due to by an external force acting at a height h from the top. Find F external magnitude and the find height h if plate is at rest. Now the force part is easy, but the h part, see what is happening exactly. I'll tell you. If you take a wall, the side view, how will the pressure be? On the top, it will be less. As you go down, it will increase more and more and more and more, isn't it? That means the plate has a tendency to become like this. Getting it? The plate has a tendency to rotate. So this is the reason the pressure is more at the bottom. This is the reason when they construct dams, this is how they construct dam ka walls. They don't construct a straight wall in a dam. That's a pretty unstable. This is how walls of a dam are constructed. You know what the advantage of this? A dam actually becomes more stable when it is full of water. Think why it happens. If you fill up this entire thing with water, when the dam is full, see what happens to the pressure. You have more pressure here. The dam is being pushed down. This pressure will decrease. If this force is more, the normal reaction is more. If normal reaction is more, friction is more. Making sense? The more water you have in the dam, the more force you exert on the ground. So you're pushing, so the dam is actually stable due to friction between the dam and the ground. This way, the dam won't get flooded away. The more weight, more water it is, dam actually becomes more stable. Think of like this. Who is pushing the dam to the right? Water ka force. Who is pushing the dam down? The water only. And that is only creating friction. So basically, you made the water fight with itself indirectly. So this is how they construct dam, walls of a dam. This is just an additional thing. But let's say in our case, you just built a straight wall. So it's a pretty bad idea, if you try to fill up your room with water. Walls will collapse. So don't try to make a swimming pool in the house. Very bad idea. Swimming pools have to be constructed in a very different way. The side walls have to be thicker at the bottom. So let's say you have a small balcony and you feel like, usko bhar dete water off se, and we can use it like a pool. Ever tried it? I used to do such weird things. So initially it will bear up, it is water, it will bear up to an extent, but if you do it frequently, one day finally the floor will collapse. Then the people living, niche unka, there'll be a rainfall. So water is pretty heavy, people don't realize it. Yeah, force external is easy. Remember, pressure at the center of mass into area. Now, where should I apply the force? Because see, if I apply the force too high, the plate will go like this. If you apply the force too low, the plate will go inside. Basically, you have to balance the torque. You don't want it to rotate. The torque due to the water and the torque due to external force should be same. Try. You got 2 minutes. Plate is actually easy. I thought of giving you a triangular plate. That would have been more fun, but you can. Alright.
If the pressure is increasing as you go down, the force due to the pressure is acting where? On the center of mass or like somewhere below?
Force is acting everywhere. Which force you're talking? F external or the force due to the liquid?
Force due to the liquid.
That is acting everywhere. Why will it act at one single point?
No, like if it okay.
Why will it act at one point? When you say normal reaction, where is the actual normal reaction acting? Everywhere. During an FBD, you draw it at the center for convenience. right? Where is mg acting? Everywhere. For convenience, you take center of mass. So don't get confused. Here, the force is acting everywhere on the surface. It's not at a single point. While drawing an FBD, we say
Now it
center
was
of
like
mass.
for convenience, where will we take, which point will we take here?
That is only for force, na? Torque के लिए वो काम नहीं करेगा. Because torque के लिए every point has a different distance.
Acha, understood, yeah.
Anyone confused with the question, please ask. If you're confused what I'm asking exactly. What I'm asking is this. Since there is more force at the bottom here, if you apply the F external here, chalo, translation will be fine. But because this is pushing more, the plate will become like this. It will rotate. If you apply F external at the bottom, the plate will become like this. So this plate won't be at vertical. It will move. It will rotate. So if I don't want the plate to rotate, but remain vertical, where should I apply the force? A by 3, no, right? It's not A by 3. Show you. See. So this is a square plate. At a distance x from the top, take a thin strip whose width is dx, whose side is a. So on the side view, the thin strip, the force from inside will be P naught plus rho gx into area dx. From outside, it will be P naught into area into dx. So P naught will anyway cancel. So this will generate a force dF, which is rho gxa into dx. If I integrate this, so the F net due to the liquid will be rho Ga x dx, which is 0 to A, which is rho G A cube by 2. This should be equal to F external. Same thing, you could have taken center of mass and done, you will get the same answer. Where is the center of mass? At A by 2 from the top. So the pressure would be rho G A by 2 into A square. So you would have got the same thing. Now, the same thing for the torque acting on that strip is what? X into dF. So this guy would be rho Ga x square dx. So the total torque on the plate due to water will be integral 0 to a rho Ga x square dx. This would be rho Ga power 4 by 3. Now for this to be equilibrium, the torque due to water or torque on plate due to liquid, water, whatever, torque due to F external, both should be equal. So this is rho Ga power 4 by 3. F external is rho Ga cube by 2 into height h. H will be 2a by 3. Right, Arjun? Check it out. So you have to apply this force at a height of 2a by 3 from the top. It is below the center, kind of expected. There's more force at the bottom. It can't be in the center. Clear? Next one. Anyone? No doubts, right? Clear with this thing. Next one. Now, this thing, you can try this as a homework. Kar lete hai abhi. That is also fun, actually. I wanted to do with the triangle. Same thing if you take an equilateral triangle. Can I do it? I'll give you 2 minutes. Find the force and the point where should the force be applied to keep this in equilibrium. You're blocking the water with the triangular plate here. Side is A. Instead of a square plate, we keep a triangular plate. I'll show the plate. I'll show the thing. Instead of square, if equilateral is triangle is used. Find external and H. There. This is the previous page. Have a look at this. Clear, no? Any confusion? Adrit, go ahead. Get this triangle. Try. You got 2 minutes. The square plate is like a standard one, like, there multiple times you can. Triangle is something new. Let's try. Just get the equation and leave it. You can simplify later. What is a force? F external is pressure at center of mass into area. The center of mass will be where? At the centroid. So that would be P naught plus rho g. The centroid is at a height of 2h by 3. That is a by root 3. Into area of a triangle is half base into height. This is pressure at centroid. I hope everyone remembers the centroid divides in the ratio of 2:1. So this vertical height would have been, this is the center of mass, and this would be 2/3 of the height, which is a by root 3. This is
So why
easy.
did we take P naught?
P naught नहीं आएगा, cancel हो जाएगा ना outside से.
तो अगर इंटीग्रेशन से करना था तो सिमिलर ट्रायंगल्स से we would have taken elements, right?
हाँ.
तो P नॉट क्यों नहीं लेना?
दोनों साइड है ना, कैंसिल हो जाएगा. आपको ना एक्स्ट्रा नेट फोर्स चाहिए. P naught will be there from inside also, outside also, ना रे.
Yes.
हाँ, if they ask you force due to liquid, P naught आएगा, but net force will cancel out. A by 8. I don't know the answer actually. I never gave this before. Even I have to try. I got bored with the square plate. I said, let's see triangle. Show you. See. At a depth x from the top. Maybe I could have given a right angle isosceles, but okay. Take a small thickness dx. And what is this angle here? 30, and this angle is 30, na? So this width will be how much? Tan 30. Tan 30 is y by x. So y, this is x tan 30. This is also x tan 30. So on that strip, the force dF will be pressure rho g x. P naught will cancel on both the sides. Into the area will be 2x tan 30 into dx. So what is the torque on that strip? Torque on the strip will be x into df. So rho 2 rho g tan 30 is root 3 x cube dx. So torque on the triangle will be 2 rho g by root 3 integral x cube dx. Limits will go from 0 to the height, which is root 3a by 2. So 2 rho g by root 3, that is x power 4 by 4, root 3 a by 2 to the power of 4 by 4. 2 rho g by root 3 into 4. This guy would be 3 9a square by 16. And now you're saying this should be equal to this into the height h. So torque due to the triangle 2 will cancel with this. 3 root 3 rho g a power 4. A power 4 is looking weird, right? And it's somewhere messing up the dimensions, kya? Rho g a is pressure into a square, nay, right only. Rho g a power 4 by 32. This should be equal to F external into H. F external is, it is simplify karna padega. How much is this? Rho g a cube root 3 will cancel by 4. This was not bad. Rho g a cube by 4 into H. 3 root 3 rho g a power 4 by 32. So H is equal to 3 root 3 by 8 a. Check. Shastika, you got greater than height A, eh? You went outside the triangle. Check. Clear, everyone? That's how we do for these kind of things. Any doubts on this thing? Like I said, the force is the easy part. Torque is messed up. 3 root 3 a by 8. What is that? That is nothing. It's not center of mass. कुछ भी नहीं है वो.
If you do the first one with integration, all you need to do is add this
ये सिर्फ ये
perpendicular
x मत ले ना. Just don't take this x and integrate. ना?
अच्छा,
बस
हाँ.
इसको integrate करना था.
Right, yeah.
So when you're doing torque, force will be on the way. Clear, everyone? Next one. Pascal's law. You guys want a break? Take a small break, na? Come back by 7:15. We'll have a short break. Any doubts so far? Anything that you're not clear, please ask. कैसा यूज किया आर्यन? बोलो एक बार एक्सप्लेन कर कैसा किया?
सर वो 2m और m मासेस का ब्लॉक ले लिया, मतलब
क्या है?
अ,
यानी सर 2m minus m by m1 plus m2 वो कर लिया क्या? Next thing. चलो let's start off. Pascal's law. The increase in pressure at a point is transmitted throughout the fluid and walls of the container. So what this thing says, right? If you increase pressure at one point, it doesn't just act there. For example, think of like this. Let's say you're sitting in your bench in the class, and let's say 3 people can sit comfortably. And this said there's a wall. Now, if a fourth person comes and tries and sits here, which person will feel the stress? Everyone, isn't it? Because when this guy comes and sits here, why will the one person keep quiet? He will go and push two. Why will two keep quiet? He'll go and push three. If you ever got into a train which is fully packed, you will understand this. Let's say if you're in a train fully packed and people are already hanging there, and one person tries to get in, the pressure comes to everyone in the compartment. Ever experienced it? If not, you should get into a Vasai train in the evening. You will really feel the Pascal's law effect. And this is a concept actually everywhere. So this thing, right? So this is the main logic behind, all these hydraulic machines and everything. So you can transfer power from one point to another, even if it's not a straight line. So let's say if you have a filled with a liquid, let this height be h, let this point be a, and let this point be b. And let's say the whole container is sealed. So in this, pressure at A is rho gh, pressure at B is rho gh by 2. Now, if you just make a small hole on the top, suddenly the pressure at A becomes, so because of the small hole, we have atmosphere pressure acting here. This becomes P naught plus rho gh. PB becomes P naught plus rho gh by 2. So pressure increases by the same factor everywhere. Clear with this? So if you increase pressure at one point, it just doesn't increase there, it will transmit everywhere. That's what the Pascal's law says. Have a look at this. Clear? Next one. So how is this useful? You ever seen this thing? This when they drill these roads and everything, they use that big jackhammer, they call it. Just goes up and down. It's actually based on pneumatic drills. When you're an IIT, first year or second semester, you'll have a lab. There's a lab called Pneumatic Lab. So what they do in this, I'm just giving a weird construction here. So let's say you have a drill bit like this. This is what they do. So you have an opening here and you have an opening here. This is connected to a pipe like this, and here there is a valve. So when you send air through this will push forward. When you send air through this, it will come back again. So by alternating this valve here, left, right, you can send the air here, air here, air here, and air here. This you can make this go front and back. You're getting how to create that motion, sir? So everything that you see, right, your crane, anything that you lift, any crane, any vehicle that you see, all are based on this Pascal's law only. The advantage is you can send power from one point to another through a pipe. You can fill this with oil. You apply pressure here, the force comes from here. So liquid's ka advantage is that even if the path is not straight, even if it is curved, you can still transmit energy. But the biggest drawback is if you make a hydraulic pipe like this, if you make one small hole here, the pressure will become P naught everywhere. The machine will stop working. That's the biggest problem with a hydraulic jack. You can send energy easily from one point to another point, but all you need is one small hole to mess up the whole system. You see your truck aate hai na, wo dump ka truck, morning ka, if you observe that BMC ka truck ka lorry, you can clearly see the pipes here. They lift this thing and put it inside, isn't it? Next time observe that. That entire hydraulic jack, right, is filled with actually hydraulic oil. So hydraulic jack. Why all that? Even your body is actually a complete hydraulic jack. Ever lifted a heavy weight? Something you carried heavy thing? You know which part of your body feels pressure? Anytime noticed? Your eyes. When you lift heavy weight, the pressure will increase everywhere at the same rate, but your eyes are the most sensitive in the body. They feel the pressure. You can feel the pressure on your eyeballs. Itna chota weight se nahi hoga utsa. You have to lift some really heavy weight. You have to put some really heavy weight. You can feel the pressure on your eyes. You know, like eyes are bulging. Because once the pressure increases in the body, this is the reason, you know, whenever people have, you know, high blood pressure, their eyes start having a problem actually. The vision starts deteriorating. Because when you have a high blood pressure, your veins and arteries in your blood are so thin, right? The blood supply which is rushing through them, they puts a lot of pressure on the eyeballs. Kabhi socha, how can high blood pressure affect your vision? Or same thing with the diabetes. These people have problems with the vision. So eyes are more sensitive. But the pressure is same everywhere, but your eyes are more sensitive. There is this thing called, you know, World Strongman Competition. I heard about it. Strongman competition, these people lift 500 kgs. Half a ton, na? World Strongman competitions. There is this guy. वो तो उसको 500 kg से कुछ भी नहीं, he'll just lifts it. I think world record was 600 or something. Blood starts coming out of the nose. AD Hall, it seems. Rehan knows the name. When you're lifting a weight of 550, 600 kgs, right? The kind of pressure the body generates is so high, blood starts oozing out of the nose. So it puts a lot of pressure. So even your body is the best thing, hydraulic thing actually. So if you increase pressure in your body at one point, it increases everywhere. So this is how this hydraulic jack works. When you go to any car shed or something, right, you have to repair the car, or you want to just, you know, replace the tire or something. You just need to lift the car by 10 centimeters. So this is what they do. You apply a force here, let's call it F1 on this area A1. Because of which you get an increase in pressure delta P, which is F1 by A1. From Pascal's law, the same pressure is transmitted here. This will be delta P1 into A2. So this would be F2. Now for this system to be in equilibrium, we say F2 should be equal to delta P1 A2, which is F1 A2 by A1. This is the force. Now, if that area A2 by A1 is 10 times, then we get F2 is 10 times F1. It's a force multiplier. You can put 10 kgs weight and lift 100 kgs weight. Getting it? So we can lift 10 kgs by using 1 kg. But there's always a drawback. You're getting something, you lose something else. So if this guy travels a distance x1, and let's say this guy travels a distance x2, volume is conserved. Whatever liquid goes down, the same liquid should go on the other side. So we have A1 x1 is equal to A2 x2. Now what is work done? The work done, W, is nothing but force into displacement, F1 x1, right? This is work done by F1. Is F1 into x1. But what is F1? F2 A1 x1 by A2. But I know A1 x1 is nothing but A2 x2 only. So this is F2 A2. So work done by F1 is nothing but work done by F2. Obviously, energy is conserved. You're not creating any new energy here. But the displacement, right? X1, X2 will be 1/10 of X1 in this example. So you get more force, but you get less displacement. You're getting how it is? So basically F into X is constant. You want more force, you sacrifice displacement. But the product cannot change because the total energy is conserved. So in a hydraulic jack, you're not getting any new energy or something. It is just you're replacing with F and F, F and X. So this is what they actually do in a car shed. You want to lift the car by 5 to 10 centimeters so that the driver can go under or repair or change the tire. You can lift a car of 1 ton weight with just like 50 or 100 kgs.
So that should be F2 x2, right?
F2x2. Yeah. Clear with this? Let's see an easy question on this.
So we don't take compression of liquid, right?
No, we don't. We take ideal liquids. No, ideal liquids don't compress. Even in
Okay.
reality, the compression is negligible actually. It's very difficult to compress a liquid. You'll have something like 0.01% error. Negligible. Clear? Let's see an easy question, theoretical one. Turning the page. Any doubts on this? Udayan, clear with this? So this is like a theory and a question. We have a liquid with 4 pistons. Force F, force F, force F. 4 forces are pushing this. Force F, there are only 2 forces pushing this. There's only 1 force pushing here. This point is A. Identical pistons. Arrange the pressures. All pistons are identical. Arrange the pressures as ABC. Which is bigger, which is least? Question is clear? The first liquid, there are 4 pistons are pushing it. Second one, 2. Third one, 1. Which is the maximum pressure? Which is the minimum pressure? Answer? Okay, let me ask you something. Just let's draw the FBD of the liquid, okay? I know where you did the messed up. You know what is this question like? Remember that two horses pulling the rope? This is an illusion here. You're thinking there are four forces, two forces and one forces. If you actually draw FBD of the liquid, forget about the pistons, you will observe all are identical. So here you have force due to the piston. Here what do you have? Force due to the wall. Here what do you have? Force due to the wall, which is nothing but the force due to the external force, isn't it? Think about it. If this force was not applied, what would have happened? The piston would have gone out, right? So basically this force F is just playing the role of a wall, na? Are you getting my point? So how do you find the pressure at any point? You draw a piston ka FBD. If you take any one FBD piston, this would be pressure at A into area is F. So pressure at A is F by A. If you take the piston B, PB into area, I don't care how many forces are applied, F by A is PB. Same thing, PC also. So what is the answer? Pressure at A is equal to pressure at B is equal to pressure at C. All are equal. You guys are thinking there are four forces. I am saying there's a force due to the wall here. There's a force due. There are also four forces here. Here also there are four forces. Aren't they identical? Isn't this the problem? Same like that piston thing there. If you tie it to a wall and if you just tie it like this, the force due to the wall is same as this force, no? It's just an illusion. There is one force. There are actually other forces acting which you're not realizing. Check it out. Easy one. They all are equal. Understood? You guys thought this force and this force will cancel, no? Means if you're sitting here and let's say your friend is pushing like this and your friend is pushing like this with equal force, you feel comfortable. Isn't that what you guys thought? Or if I tie you one side to an elephant and another side to an elephant and pull you with equal force, two identical elephants, you feel comfortable. You will be torn apart into two pieces. You feel a lot of pressure. So don't try such things with elephants. Next one. Clear? Next thing is a barometer. So what is this barometer? Consider a 1 meter long tube filled with mercury. And is inverted into a cup of mercury. And we observe the mercury level drops. Creating a vacuum at the top. So we have a cup of mercury. So initially this is filled with mercury. Make sure there are no air bubbles. Then we notice some of the liquid, right? Liquid flows back into this mercury here. Right. And in this top part, you get a vacuum. Because think about it, if the liquid simply just comes down, there is no one to occupy the space, right? And at this point here, if you see, there's a P0 atmosphere pressure. So initially, when this experiment was done, this experiment became very famous for creating vacuum. During 1700s and 1800s, people used to think vacuum can be created only by a devil. And people had their own feelings. They think vacuum cannot be created by humans; it can be created only by devils. So this experiment became famous for a human could create a vacuum. Maybe this guy is a devil. So if you draw the FBD of the liquid, so upper there is a vacuum here, so there is no force. That's the reason you should not have any air bubbles. If you have air bubbles, this part will not be vacuum. There will be some pressure there. Your own weight mg, and bottom se pressure is P naught into A. So P naught into A is equal to mg density, area, height h into g. So this height of the liquid column is given by P naught by rho g. Have a look at this. So here few precautions is there should be no air bubbles. And can you tell me why can't we use water?
The density of mercury is much higher, so the length of column will be much less.
expand करने पाएगा
be a
then.
very long.
वो एक है. What else? That is fine. One. What else?
The water may evaporate.
Yeah, water may evaporate and create a vapor pressure at the top. Getting it? The water will create a water vapor on the top, and you won't get vacuum. So we don't use water in this. If we use water, there would be vapor instead of vacuum. If you put water in vacuum, it starts boiling immediately. You will learn in surface chemistry what is boiling point exactly. When the vapor pressure becomes equal to external pressure, it boils. If there's vacuum outside, what is the external pressure? 0. There is no one to stop the water from boiling. It will just start boiling off. So let me write this formula here. So the height of this mercury column or liquid column we will do good problems on this thing in gravitation. Right now, you'll not have much on this. H is equal to P naught by rho G effective. So if the system is accelerating, the gravity would change. For mercury, if you substitute the values, pressure is 10 power 5, rho is 13,600, and G is 9.8. This thing comes out to around 76 centimeters of mercury column. That's why we keep saying 76 centimeters of mercury column is 1 atm. So sometimes in the exam, how they'll give you? They will say the pressure is 20 centimeters of mercury column. So what he's saying to say is the pressure is rho mercury G H. So that is 13,600, 9.8 into 20 centimeters is 0.2. That's your pressure. Same thing, instead of mercury, if you actually take water, the height would have been 10 power 5 by 1000, 9.8. Approximately you get 10 meters. It's huge. Clear? Let's see a question based on this. Let's say on the surface of the Earth, you took this mercury column here, and you got a height of 75 centimeters. pressure is P naught. Then this whole setup is taken above the Earth's surface. Here the gravity has become G by 3 and the pressure has become 2 P naught by 3. So let's say P naught by 6. Find the height of the liquid column. So 75 centimeters is P naught. The barometer shows 75 centimeters of mercury column. Simple substitution on surface. Find the height of mercury column. When gravity becomes G by 3 and pressure becomes P naught by 6 when it is taken a height h above the ground. Get it? Simple formula substitution. There, have a look at this with it. Clear? Yeah, 37.5. Get it? Just substitution there, nothing much. It's an easy one. So this will be a good question in gravitation. Gravitation question aisa hoga. If the height of the liquid column is 90 centimeters and the pressure is P naught, find the height above the ground. So we will play there. I'll show you when it comes in gravity. So what's the answer? So initially H is P naught by rho G. You're saying this is 75 centimeters. Now the new height H dash, pressure became P naught by 6. Rho is rho only. Gravity becomes G by 3. So this is 1 by 2 P naught by rho G. That is 75 by 2. Easy? Next one. Now this barometer which we have, so this is filled with mercury. You take 2 points here. The point A is here and the point B is here. A is on the top and B is at somewhere in the middle. Okay. Now what happens if you make a hole at A and if you make a hole at B? What happens to the liquid column basically? What happens to liquid column, or I'll simply say what happens basically. When a hole is made at case 1, you make hole at A, so B there is no hole. Case 2, hole at B. Case 3 पे करते हैं, hole at A and B at the same time. What do you think will happen? I asked this last time, then they said the glass will break. I said, yeah, don't worry about that. Let's not break the barometer. What will happen? What will happen? Case 1, nothing. Case 1, height rises. Case 2, height drops. Case 3, height remains constant. Can h become 0 quantitatively? Yeah, case 1, height becomes 0 actually. First one, say you make a hole at A. The moment you make a hole at A, the air will rush in because inside vacuum, no? Air rushes in since it is vacuum. So once the air starts coming out, this pressure becomes P naught, and there is no one to balance the weight. Na, then the reason the liquid was going up is because, and here also it is P naught. Then why will the weight be balanced? So upper P naught, niche P naught, the liquid goes down. Liquid is pushed down, and H becomes 0. Make sense? 2 is interesting. What happens if you make a hole at 2? What are you guessing will happen?
So
Hmm.
the first one, if the mercury column is filled to the top and then you make a hole,
You
then
can't
nothing will
fill it to the top, na? It is there 75 centimeter story to wahi tha. There'll be always vacuum there,
happen.
na? Why will you fill it up to the top?
Uh,
You can fill it up to the top if you use a length less than 75 centimeters, 76.
yeah, but then if that we do, then even if you
Even
make
then,
a
it's
hole,
same
nothing
story,
will
na?
happen.
Even if you make a hole, that P naught will push you down, isn't it?
So, but isn't it experiencing P naught even when there is no hole, like or the glass is balancing?
When there is no hole, there is vacuum, God.
No, I'm saying
If
when
you just
there is
seal
no
this,
vacuum.
then this wall is pushing down, na? There is no pressure there. If you keep exactly 76 centimeters, liquid is just touching there. Why will there be pressure?
Okay.
See, B mein kya hoga? This is interesting. What is the pressure here? P naught? Here the pressure is P naught. If you take at a height x, what is the pressure at inside here? P naught minus rho gx. Where is the pressure more, inside or outside? Outside. So
Outside.
the moment you make a hole, the air will rush inside, creating an air bubble. It won't come out like a fountain. Creating an air bubble. But then what happens? Air is lighter than mercury. Since air is lighter than mercury, the air bubbles will float up. So then the pressure here becomes P naught. The liquid will push me down. End of the liquid column will be 0, but the reason is a little different. Creating an air bubbles, which rises up and fills up the vacuum. And liquid comes down. So end of the day, both the cases, the liquid column becomes 0 finally. But most people will think like maybe the liquid will come out like a fountain. That won't happen. Which rises and fills up the vacuum. And H becomes 0. What happens if we make a hole at the same time? Now that's nice. What do you guys think will happen? Now you get a fountain. Two things will happen at the same time. The moment you make a hole here, this side becomes P naught. You make a hole here, B, this thing becomes P naught. This is P naught. So from the top, if you try to measure here, this pressure, right, is P naught plus some rho g x. So this liquid comes out. At the same time, even the liquid here starts going down. Both will happen at the same time. So some liquid comes out. And at the same time, the liquid is also going out like this. The liquid is going back to the container, liquid is also coming out sound. It's just leaking everywhere, basically. Making sense? So some liquid goes into the cup. And liquid also comes out. You get both. Clear with this? As the liquid starts coming down, at this point, right, fountain will stop, but the liquid will continue to go down into the cup. Eventually, height becomes 0. Mostly theoretical question. There, you can destroy barometer like that. Any doubts on this? There is no way liquid fountain will not rise. That's the problem. The liquid won't rise. Someone said liquid will rise. Think about it logically. Yeah. If the liquid rises, meaning you gave extra potential energy, isn't it? Where did you get this energy from? Making a hole does not create energy. You can lose energy. Systems are fine with that. You can't gain energy. So liquid level rise on a there's no chance only. Clear with this? Last one for the day. We have a liquid here. We have an open pipe. There's an open end on both sides. So let's say this is 50 centimeters, this is 50 centimeters. So exactly kept it in the middle. Right? You kept it exactly in the middle. And now what you did, you can. Getting it? So now what you did, you sealed the open end. Right? So once you close the open end, what happens? So the air will be stuck there. The open end is sealed. This thing is still 50 centimeter and that is 50 centimeter. That you didn't mess it up. Okay? And let's say this entire liquid is also mercury only. Then you sealed it and you pulled it out now. Pulled out by 25 centimeters. So this thing becomes like this. This is still sealed. In this process, what happened? The liquid will not remain at the same height. The liquid actually went up for some reason. And you need to figure out why it went up. So this guy was X.
Sir, only
This
upper wala part was sealed.
Only upper is sealed.
Okay.
The upper end is sealed. Let me write that thing. The liquid can come from bottom. Getting it? It's pulled out by 20 centimeters, this thing. So liquid level goes up. Find X. Assume temperature is constant. Questions clear? How to do this? I think solving is a little bad. You can just get the equation. Try. I'll give you a minute and then I'll show you. If you pull it above, pressure from below. Yeah, when you pull it out, the volume will expand, na? So pressure drops. So here pressure will be less than P naught. So this P naught from the bottom is pushing it up. That's the reason, yeah. Show you. You have to use P1 V1 is equal to P2 V2. Number of moles are constant, temperature is constant. So why he say you'll get a, what is the old pressure? Before pulling up pressure kitna tha? P naught, na? Because it's exposed to atmosphere, it will be the same as before. P naught 3R rho H naught G. You get a quadratic, Ranika. That's the problem. I said that's the reason I said you can't solve. You get a quadratic here. Look at the diagram here. Let's say when you sealed it, this is P naught. This is 50 centimeters. And when you sealed it and pulled it out, the liquid has gone up by X. So this guy is 75 minus X. Pressure is P dash. So we are using the equation P1 V1 is equal to P2 V2 because temperature is constant. P naught, volume is area into 50. P dash, area into 75 minus X. So P dash will be P naught 50 by 75 minus X. Fair enough. That's your pressure in terms of X. Now, at this level here, pressure is P naught. And this height is X. So P dash plus rho G X should be equal to P naught. No, because pressure on the surface level is P naught. But what is P dash? P naught 50 by 75 minus X plus rho G X is equal to P naught. But I already know P naught is nothing but rho G 70. I'll take it as 75 centimeter. That I should have given you. 1 atmosphere pressure is 75 centimeters of mercury column. 75 number is good. 76 cancelling will be a headache. So I can replace that here. So basically rho and G will cancel off. Rho G 75, 50. Everything I'm taking in centimeter on both the sides, so it is fine. This is rho G 75. Rho G cancels on both sides. Then you're left with 75 into 50 plus 75 minus X into X. 75 minus X into 75. That's why I get a quadratic. Is there any way to simplify this? 75 into 50, 75x minus x square, 75 square, 75x. You get x square minus 150x. plus 75 into 25, that is. You solve this, you get x का answer. I'll leave it to you. I don't think you'll get something good. क्या था इसका roots? Check it out. Look at the steps. The final thing you can figure it out. Understood the steps, everyone? Positive number आएगा ना? I think you should get. Can someone find out the answer? I'm just wondering, quadratic तो दो roots कैसा आएंगे? मतलब, if x comes greater than 50, it is wrong, ना? That is 1. So you should get x between 0 to 50 का बीच में. How much is this? 150 plus or minus. Numbers are not too big actually. $75 plus or minus 150 square. 75 into 25, that is 100. 150 square is 22,500 minus 7,500. How much is that?
15,000.
15,000, no? Root
So it's not a
15,000, no, 10 root 150 by 10 root 150 by 2. So you're getting 75 plus or minus root 150 into 5. Root 150 is how much? Close to 13. 13 by 65. Yeah, approximately 13 and 136 are. You don't take the bigger one. You take the smaller root. It is exceeding 1 meter actually. That's your answer. Clear? It's a good one. A little KTG and this thing. This question I could have asked like this also. The container is pushed inside by 25 centimeters. Reverse. In that case, it will be a compression. It should be 10 root 150. Denominator में 2 है ना? Check it out. So I could be wrong. Clear with us? With that, we'll wrap up for the day. The test is still online on KTG and everything, so make sure to give. And the next class, when we catch up on Friday, we'll continue from here. We'll start doing bind force, which is quite important. I think next class will be full going for bind force only. If time permits, we will do fluid dynamics introduction, streamline flow. So streamline flow, actually questions are, there's only one main questions on that, but most of it is theory only. You should be able to finish it off. Okay, with that, we'll wrap up for the day. So any doubts, anything, please stay back and ask. Also free to leave. So take care, stay safe.